Hello students, in this video we are going to see ensemble techniques. Ensemble technique is nothing but the combination of multiple models to improve the performance of a system. Now we will start simple ensembling techniques. There are three types: max voting, averaging, weighted averaging, and advanced ensemble techniques are bagging, boosting and stacking. This voting and averaging will be applied in this advanced ensembling techniques. So voting is nothing but different models are trained and different models will give different results. Finally, the major results will be considered as the final one. And bagging, it is also known as bootstrap aggregation. Here, instead of focusing on different models, we'll focus only on single model but providing a different subsets of data. And all the predictions are averaged. Averaged in case of regression and voting in case of classification. Remember one thing, if we are focusing on the classification problem, we can choose voting technique, and if we are focusing on regression algorithm, we can choose averaging, weighted averaging. Then in the boosting, here the models are trained sequentially with each subsequent models focusing on the errors of the previous one, and those identified errors are rectified in the next training process. We will see some of the boosting algorithms. And in stacking, similarly the multiple models are used for a prediction. All these multiple model results are given to the meta model, which is considered a superior model, and this meta model then finally make a prediction. So you could have a better understanding on seeing this diagram. Here bagging means as I said already, here a single model is trained on different subsets of data. Here the same model, if it is a decision tree or if it is a support vector machine, the same model will be trained but for different subsets of data, and all these results are combined to produce a single result. If it is a classification, will focus major voting. If it is regression, will perform averaging. So this step is called as bootstrapping, and combination of the results is known as aggregation. In case of boosting, the models are trained in sequential manner. You could see that in bagging, all the models are trained in parallel. If we have three subset of data, the three models will be trained in parallel. The three results will be provided based on the weighting or weighted averaging or majority voting. Will choose the result. But in case of boosting, the models are not trained in parallel. It will trained in sequential. Initially, the data set is given to the model 1 and it will provide some results. If there is any misclassification, those misclassified ones will be given more importance in next training. Similarly, this process continues. The final result will be the boosting result. Then in case of stacking, we'll train different models, and all those different models results are given to the meta model. So these are called as base learners, and the superior one is called as a meta model. Based on these three results, the meta model will train the model as well as it will provide a result. So now let's see how the voting and averaging works in this video. Okay, so there are two types of voting: hard voting and soft voting. For example, if we have three classifiers, that is three models providing three results A, B. So we can conclude that the final result is A because the majority wins. In case of soft voting, we'll go for average of the probability given to the class. So assume the three models giving the three results. For example, the model 1 result provides us 0.3 for A and 0.2 for B, and similarly 0.47 for A and 0.32 for B, and 0.53 for A and 0.40 for B. So we will take an average of all these values, and the A is 0.4333 and B is 0.3067. So based on these values, the highest probability will be considered as a final value. So this is just a visual representation of the voting classifier. Hard voting, here we could see three models, M1, M2 and M3. Model 1 is providing result 1, model 2 is also providing result 1, model 3 is providing result 0. We can go for majority, so the final result will be 1. But in case of soft voting, will determine the probability of each classes. So the output could be either 1 or 0. So the probability of 1 in model 1 is 80% and the probability of 0 in model 1 is 20%. Similarly, the model 2 provides 90% of probability for the class 1 and 10% of probability for the class 0 and 20% of probability for class 1 and 80% of probability for class 0 on averaging. We are going to take the average of all the 3 for 1 as well as 0. So the average of 1 is 63% and the average of 0 is 36.6%. On combining the average of 1 and 0, we can conclude that the majority or the highest average is 63%. So the final result is 1. Anyway, you could see that 3 models, here also 3 models. The final result is 1, here also the final result is 1. But the obtaining of the result, the process of obtaining the result is different. In case of hard voting, we'll count the major values or majority wins. And in case of soft voting, we'll determine the probability of each classes and the highest probability will be given as a final result. So you could see here, I am going to demonstrate the voting technique. I am going to consider the data set with 2 features, x1 and x2, and for the 2 features we are having some binary labels 0 or 1. The first row is 1, 2, 2, 2, 3, 4, 4, 3 and 5, 5, and the corresponding output is 0, 0, 1, 1, 1. I am going to consider x as well as y. Here x is the independent features and y is the dependent features. We are going to divide the data set into x training as well as x testing, and 80% for training and 20% for testing. So first 4 rows, not first 4 rows, randomly 4 rows are chosen for training and the remaining 1 row is chosen for testing. And we could see the 2, 2 is chosen as a testing data set. For 2, 2 we should get the result as 0, because if the feature is 1 and 2, the output is 0. The feature is 2 and 2, the output is 0. 3 and 4, 1, and it goes on. As per my code, and 2 and 2 is selected as a testing data, so the corresponding y test will be 0. If I train my model, it should provide the result 0. If not, the accuracy is not that good. So we are going to use 2 models. One is logistic regression as well as decision tree classifier, and these are the 2 instances of those models, log classifier as well as tree classifier. I am going to use a method called voting classifier, and this is the syntax of estimator, which is nothing but a list of tuples. The tuple contains the name as well as the instance. So the logistic regression classifier instance, and I am just providing the name as LR. It is just a syntax, we can't omit it. And the tree classifier, and the name is DT, and what type of voting I am going to design. So voting equal to hard means the logistic regression model, it is model 1, it provides some result. Decision classifier, it also provides some result. If we want to have more than 2 models, we can include it here. So we'll have 3 models or 4 models. Based on all the 4 models, it will take a majority count. So yes, so we are going to fit the training data, that is the 4 data we have divided previously, and we are going to make a prediction of it. And finally we are making an accuracy, it is 1. So on giving the x test, we are getting exact value 0, so the accuracy is 1. If we train for more number of data, there may be some misclassifications. So let us understand just the working behind the hard voting, right? So we have divided the model into 2, logistic regression as well as decision tree classifier, and if we separately fit the model and giving the x test for each model, both the models are providing 0, so the final result is 0. If anything is, if any of the model provides the result is 1, the final accuracy will be 50%. If both are 1, 1, then there is a accuracy is 0%. Luckily we are having both the results are 0, so it is accuracy is 1. So its accuracy is 1. Now the only change we need to perform for soft voting is we need to represent the parameter voting equal to soft here. The same process will be continued and the same prediction, accuracy, everything is same. How the working of soft voting here. So we know the soft voting is based on the probability, and same the probability is calculated for logistic regression and decision tree, and here we are getting 2 values, 0.51865381 and 0.4813 something, and 1 and 0. So these are all the probabilities provided by the 2 models, and we need to take the average of the model. So on taking the average, we are getting 2 values, 0.7593269 and 0.2406. and the probability of this class is higher. The probability of class 0 is 0.7593 and probability of class 1 is 0.2406. So the final result is class 0. That's it. Thank you.